Hello, so today we will be doing something which is conditional probability based theorem and so on. So let's start with conditional probability. So like conditional probability. Okay, so initially we must ponder upon the question, what is conditional probability? So let's say if you're rolling two dice, you're rolling two dice, and I say the first dice has 3, and then the second dice must have 6. Okay, then what is the probability that I'll get this combination? So currently you know that the first dice is completely 3, right? So the possible cases are 3 1, 3 2, and so on till 3 6. So actually my probability here comes out to be 1 by 6, because I know for a guarantee the first dice is 3. But if I had asked you this question, what is the probability of 3 6, as in like what is the probability of 3 6, you would have said what? It is the total cases 36, and what is the case 1 by 36. So here you can see, here there is no constraint on the first dice, right? Here we know the first dice has happened, something like this. So basically we define conditional probability with something like P E by F. It means simply what is the probability, let me do this, what is the probability of E such that F has already happened. Okay, so this is the simple meaning of conditional probability. Okay, as simple as that. So basically this thing comes out to be the formula comes out to be P E by F is equal to P E F. When I don't write anything in middle, that means intersection, by P of F. You are supposed to remember this formula for life. This is the single most important formula. Okay, so how does this come? Very logical. So basically let's say I have P E F. What does this mean? Probability that E and F have happened together, right? And I have P E by F and P F. So basically what does this mean? This means that probability of E such that F happens into probability of F happens. So here what are you seeing? That E also happens, F also happens, right? So this is a rudimentary understanding. It's not like a mathematical proof. So this becomes equal to PEF. So that is how we get this equation. So PEF is equal to PE by F into PF. So we get this equation from this. Okay. And then let's do one sum, I guess. That would be better. Okay. Let's say yeah, let me find a good sum. That would be that. Okay, by the way, yeah, so for example, a coin is flipped twice. Okay, then what is the conditional probability that both of them will land on heads, considering that the first flip is a head? The first flip is a head. What is the probability the second one will be a head as well, right? So how do you figure it out? What is the formula? PEF. So basically it is P2H such that first one is a H, right? So how do we find this out? This is nothing but equal to P of 2H into 1H by P of 1H. This is very logical, but I am going through all everything. So what is the probability of two heads such that the first is a head? It's 1, right? Head by what is the probability you'll get at least one head, that is head and head tail by 2, so it becomes half. So you understand how to approach these problems. Like this is a very easy kind of problem. Like this type of problems, they directly ask the question and this is how you proceed. I took a easier sum so that like it's easier to solve here on camera. Now this thing let's say if I get this equation in a ulta way, right? So for example, P of EF is equal to P of E by F into P of F. So I can do it in a multiplication rule kind of thing. Okay. So what do I mean by multiplication kind of rule? Like, so if we have P E1, E2 till En. Okay. This you can break this as P E1 first. Okay. Into P E2 by E1. Then what? P of E3 by E1, E2, and so on till the end. Okay. How does this happen? See, simple logic. P of E1 into P of E2 by E1 is what? P of E1, E2. This becomes what? Wait. This part. Okay. This part becomes what? P of E1, E2. And then what? This part and this part becomes what? P of E1, E2, E3. So at the end of the day, what we'll get? Till the last, you'll get P of E1, E2, E3 till En. Right? That's a simple logic, right? It's not that hard. So for example, let's do one sum. So basically, let's say there is a deck of 52 cards, right? And they are divided into 4 piles of 13 cards each. So what is the probability that each pile has exactly one ace? So if you know every 4 of them have 4 aces, so what is the probability each of them will have one ace? Okay. So the aces will have to be in a different pile, right? So what are the cases? So basically all in different piles, or like say the spades, hearts, diamonds in different piles, then the spades, hearts in different pile. These are the cases. Okay, wait, let me just scroll down. And the spades in different piles. These are the 4 cases that can happen, right? Okay, so so what we have to find out is nothing but what is the probability of all of this happening together. Then like P of all in different piles is the probability we are going to, but if you multiply all of the cases, it's the same thing. So let's say we'll define this as P of E1, E2, E3, E4. Okay, these are the wait, let me mention this. 7. This is 1, this is 2, this is 3, this is 4. Okay. Actually do the reverse, that is better. 4, 3, 2, 1. Okay. So now how do you move forward this? Using the earlier formula. Use the earlier formula. So use the earlier formula. First we have to find E1, right? E1. Probability of E1. What is probability of E1? Ace of spades is in different piles, which is obviously true. Ace of spades will be in any one pile at a time, right? There is no other probability, so it's 1. Let's go to P of E1, E2 by E1. So basically consider one pile has the ace of spades. Now remaining 12 cards can be any of the other 51 cards, right? So basically the ace of hearts might be among them is 12 by 51. So if it is a different card, that will be what? 1 minus 12 by 51 is equal to 39 by 51. How? Basically simple logic. Don't overthink. So basically there are 13 cards here, right? one of them is the ace of spades, and out of these 12 I have to make sure that these 12 are in the hearts. So this is the probability of 12 by 51. The rest remaining cards is 51 now, because 1 is already decided as spades. So 1 minus this would be your answer. Simple logic. So now probability of E3 such that E1, E2, right? So let's say ace of spades and ace of hearts are now in different piles. Okay, now remaining how many cards will be there? Same logic, 1 by something by 50, because 2 cards I have already decided. And now earlier it was 12, so now it is 24. Simple logic. So it will be 26 by 50. Okay. So now how can you move to the next thing? E3. Okay. So now it will be what? 49. Here would it be 36. Simple logic. This will be 13 by 49. Okay. So you now multiply all of this, you'll get the answer, right? This was a simple logic behind this big question. Okay. Okay. So this is basically what conditional probability means. So now we will talk about Bayes formula, not Bayes theorem, but Bayes formula. So basically we'll consider this thing. Let's say E. Can I write E is equal to EF union EF dash? This is true because see, if let's say let's say this is one of it and this is F, right? So what is EF? EF is this area. EF dash is E into F dash. So okay, so this is E and this is F. Okay, this is E, this is F. So F dash is this area and E into F dash is this area. You are getting E itself, right? So this is right. So we can take probability of E is equal to probability of EF union probability of E F dash, right? So now you can write this as what? Probability of E by F. Why is my voice cracked? Into probability of F union probability of E by E of F by into probability of F dash, right? Now you can write F dash as 1 minus PF as well, right? So actually this is just the formula for Bayes theorem. This is the base of your Bayes theorem. This is the Bayes formula, sorry. So basically let's do one sum so that you understand it correctly. So basically the idea, this is a by idea I have given you, but this can be extended to, this is what you actually called, something called the total probability theorem. I guess in books it is given as total probability theorem, but this is called the Bayes theorem as well. So I'll explain it empirically as well. So basically let's say let's say this is my total A. Okay, not A. This is my total sample space, and I break this down into events. So let's say this is one event, 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 this is one event. And now let's say I have an event like this. This is my A. Okay. This is my A. So what is the probability of A? You must say, right? So can I write the probability of A to be this area plus this area plus this area plus this area? Okay. So can I write probability of A to be something like probability of E1A plus probability of E2A plus probability of E3A and so on. So I am considering these to be E1, E2, E3. Okay, E1, E2, and so on. Okay, these are my considerations. So now, for example, now we'll show you this. So basically, this will be equal to what? Probability of E1 E1 by A into probability of, we can write this, P of A by E1 into probability of E1. You can write it something like this, right? And so on. So now if you notice in this area, right, in this area, what is the intersection with this and A? 0. So this value comes out to be 0. With E2, it is this area, so we encompass this area, and with E3 it will become this area, and so on. At the end of the day, it will cover the whole area, right? So the probability of A comes out to be this. So this proof has been done for only 2, and this is for a general n case. So this is basically called a total probability theorem or Bayes theorem. Okay, so this is how your main idea of Bayes theorem and total probability theorem works. So after this we'll go on to Bayes theorem and we'll then solve some sums. Now how do we get something that we used to call Bayes theorem? Okay, simple logic. Let's try to do it. Bayes theorem. So Bayes theorem. So now what is P of, let's say, E by F? Simple logic. P of E by F can be written as P of, let's say, EF by P of F, right? That is the main logic, right? So now what I can do, I can write P of EF as what? P of FE, can write it, by P of F, right? So then it will become P of F by E into P of E by P of F. Okay, now then I can finally write P of F by E into PE into, I'll apply the total probability theorem here. So it will become what? P of, okay, let me write this here. Okay, so it will become what? P of, let's say, whatever the initial cases, all the cases are. I can't write the all cases here. So here just you have to write total probability on PF. So if you notice this part, okay, so this part is your Bayes theorem. This is your Bayes theorem, nothing else. Your Bayes theorem comes out to be P E by F is equal to P E F by E into P E by P of F. This is a Bayes theorem. Logically, this is a Bayes theorem. So if you saw, like, okay, so basically till now, so I think everybody, most of the people don't even understand how this came, because books don't cover that much, except some books. So I think from this basic understanding of what conditional probability is, we have derived what total probability theorem is and what Bayes theorem is as well. So we have covered everything. Okay, so with this we have covered everything related to total probability theorem and Bayes theorem as well. So like one basic sample is question I'll do, and every question is of the similar characteristics as well. So for example, there's a lab test. Okay, there's a lab test that is 95% effective. Okay, means it can give you 95% of the times it will give you wrong answers. Okay, so let's say a false positive for healthy people comes out as 1%. It's 1% of the time for a healthy person it will say it is sick. Okay, and then so basically, and then 0.5% of the population has the disease. Okay, so you have to find what is the probability that the disease that a person, yeah, so disease is there such that the person tests positive. What is the probability of this? Okay, so let's say I am giving the name of this event D, which is a person testing positive. I'll name this event D. The person E will become nothing here, person testing positive, and let D become, let's say, person testing positive and he has the disease. So basically it's like the true positive. Okay, so what is, I have to find what the person is testing positive and has the disease after we are knowing that the person is testing positive. So we have to find P of D by E. So that is nothing but P of DE by P of E, or what is it, by direct base theorem, P of D by E into P of D by P of E. So okay, so what is the PE of D? That what is the probability that the testing is positive if he has the disease. That means how many times is it effective? 0.95 into what is the probability that that person has the disease? This is 0.5, so 0.005. I'll put an X, that would be better. Okay, niche I have to do total probability theorem now. So what is my total probability theorem of E testing positive? So either it has tested positive when it is true and tested positive when it is false. Okay, so I have to do P of E by D into PD plus P of E by D dash P of D dash. This is a simple logic. Okay, so now what does this value come out to be? P of E by D, we just calculated 0.95 into 0.005 plus, so basically now this is the false positive case, so 0.01 into 0.995. So you calculate the whole thing and get the result. That I am not calculating. So this is the main logic of how do you solve base. This logic is same for every sum. Nothing. You write the base theorem, you find the individual what it means, do the total probability theorem below, and you have solved base theorem. Okay, any base theorem sum you are given, you should be able to solve using this formula. And now this is the basic idea behind any base theorem sum.